Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
Avogadro's number, the mole, and moles of compounds. So, chemists measure the amount of substance in a unit called the mole, right? So this is a convenient way of counting atoms, and it allows chemists to make predictions about the masses of different substances that are involved in reactions. So 1 mole is the Avogadro's number of particles in a substance. So 1 mole of an atom contains 6 times 10 to the power of 23 atoms, no matter what the element is it. Right, so this was discovered or worked out by a scientist called Avogadro. So if we were going to go and calculate the number of moles or the number of molecules of water in 0.5 moles, all you do is your Avogadro's number, which is 6.02 times 10 to the power of 23 times by 0.5, which would come out as 3.01 times 10 to the power of 23. So the term mole is also used to talk about mass. So 1 mole of a substance is its relative molecular or formula mass in grams. So 1 mole of carbon has a mass of exactly 12 grams. So because magnesium atoms each have twice the mass of carbon atoms, 1 mole of magnesium has a mass of 24 grams. And 1 mole of any element has the mass of grams same to its relative atomic mass. So, for instance, 1 mole of iron has a mass of 56 grams. 1 mole of sodium has a mass of 23 grams. 1 mole of sulfur has a mass of 32 grams. And 1 mole of boron has a mass of 11 grams. The mole of a compound contains 6 times 23 molecules, so it has a mass that is equal to its relative formula mass, right? So we can also go and use this to work out for compounds such as H2O, which has a relative formula mass of 18, so 1 mole of water is 18 grams. So a mole of carbon has a mass of 44 grams. So this also works out for ionic compounds. So a mole of sodium chloride has a mass of 58.5 grams. Oxygen gas, which is diatomic, so its relative formula mass is 32 because each oxygen atom has a mass of 16 grams each. An element's atomic number defines it. So an element with 17 protons will always be chlorine. However, an element's mass numbers can vary, which means that it can differ the number of neutrons. So, for instance, hydrogen can have one form with no neutrons, which is hydrogen. Hydrogen can have one with 1 neutron, so it would have a mass of 2 instead of 1, and that would be called deuterium. And it can also have a mass of 3, so it's got 2 neutrons, and that would be called tritium. So the relative abundance of an isotope is the percentage of atoms with a specific atomic mass found in a naturally occurring sample of an element. So the average atomic mass of an element is weighed average, calculated by multiplying the relative abundances of the element's isotopes by their atomic masses and then summing the products. So for instance, if you have chlorine, so 35% of chlorine has a mass of 37, 65% has a mass of 35, so you'd go and work this out, 37 times 35, you add to that 35 times 65, then divide that by 100, which would go and give you 35.5, which is what we know the mass of chlorine is. Could also do this for copper, so 69% has a mass of 63, while 31% has a mass of 65. So you would do 63 times 65 plus that 65 times 31, divide that by 100, which would give you 63.
Thanks for watching.